Good morning, everyone. People online.
Good morning, sir.
Okay. I don't think I'll be able to write anything today. I don't have that e-pen. I'll try to get it together. Okay, so let's start from the second measure, measure of dispersion. So yesterday we saw two measures. The first one was range and the second one was quartiles. Okay, so range is the difference between minimum and maximum. So it is not a stable measure because of outliers. The advantage is it takes only two values, min and max. So that way we can interpret that your data lies between these two numbers. Then we have quartiles. So quartiles are dividing the data into 4 parts. And we saw the different values for each of the quartiles, Q1, Q2, and Q3. So the interpretation is Q1 represents 25% of the data starting from the minimum value. Q2 is also known as the median, and Q3 represents 75% of the data starting from the minimum value. Okay. Now, there are other ways in which you can divide your data, not just quartile. There are other measures, for example, decile. Okay. Deciles are dividing data into 10 parts and then commonly used in education, which is percentiles. Okay, where data can be divided into 100 parts. Okay. Now let's go to the next section, which is variance and standard deviation. What is variance? Defects. Difference. Difference of what?
Between two particular points.
Okay. Then what is standard deviation?
Differences let's say we have two data points. So what is the significance of variance in the two data points difference from each other?
Okay. Anyone online? What is variance and standard deviation?
Spread of observation.
Spread of observation. Okay. From where? When you say difference between points or spread of observation, there has to be some reference point, isn't it? What is that reference point? Are we talking of data from left, then the difference, or from the right, the difference, or what? It is the difference from the mean. Okay, from the center, how is the data spread on both sides? Okay, so that is how you calculate how much is the data spread on both sides when I draw my curve, okay, or the data. So the central point or the mean, you first plot it from the mean, how is my data spread on both sides? Okay, so if you look at the formula also, you will have the difference of mean. Okay, it is x minus mu, the whole square. Okay, the reference point minus the mean squared and then divide by total number of observations. Okay, now which is a more stable measure, or which one should I use? Is it variance or is it standard deviation?
So your screen is not visible.
I have already shared my screen. 1 second. Is it okay now?
Yes, sir. Thank you.
I'll try to draw, but I don't trust my drawing skills. Now, suppose let's say this is the mean. Okay, this is mean. Now, deviation is always on the left and right of from the mean. So this is 1 point, this is the next point, and this is the next point. Okay, so this will give me how much is the data spread from the central point. So there are two measures, variance and standard deviation. So which one is more stable, variance or standard deviation? Standard deviation is more stable. Okay, why? Why can't I use variance?
Because of the spread in the center of the distribution.
Even variance is that same thing, isn't it? So how is variance different from standard deviation? Okay, so let us understand this with an example. We'll take this same data that we had. So let's assume that I have these property prices. I want to find out whether, I want to find out what is the variation in the data. So the formula I have is, one is for variance and one is for standard deviation. So let us see what is the variance formula. It is x minus mu whole square by n, and then so I don't want to apply the formula. I can directly use the variance. So we have a function called var.p for population and var.s for sample. Okay. Now assuming this is a sample, so I'm going to use this variation of sample. And now it says the variance of this data set is 844.8. Okay, you will get a different number, which is going to be a big number. What is the relation between variance and standard deviation? Have you done this chapter, by the way? Let me first clarify that.
It's like one way, one level thing only, like this is variance, the formula.
Formula is fine, but what is the use of standard deviation? What is the use of variance?
Nothing.
Nothing.
We were never in the phase like we came to know why we are doing, where we are doing. We just got the formula, we just got the, like for the testing, we just got the data set, just implemented.
See, applying formula is simple, but you have to understand what is this number representing. See, if I have to again explain from scratch, it is going to take another 2 weeks at least, 4 classes. So I suggest that you read up on all these topics. I'll just explain it in brief. Okay. Now, variance, the value is 844.8. Now, the relation between these two is standard deviation is the square root of variance. Okay, that is the relation between SD and V. So standard deviation equals square root of variance. Okay. Now I asked you this question, which is a more reliable measure, variance or standard deviation? Now, why is the answer is standard deviation? Now, why variance is not used? Now, if you look at the formula of variance, it is square. Okay, so let's assume that this is property price. So what is a unit of this? What is a UOM? What is unit of measure? Rupees. If it is in India, it is going to be rupees. If it is some other country, that country's currency. Okay, so if this is rupees, according to the formula, if I apply the square, what happens to the unit? Unit will also get squared, isn't it? So if I say variance is 844 rupees square, what is the meaning of that? There is no meaning, isn't it? Rupees square does not have any meaning. So I want to say that the difference between two houses, the variation is so many lakh, not so many lakh square. Correct? So that is the reason why variance as such does not have any meaning. When we take a square root, so if I use square root of the variance, I get a standard deviation. Now, if I say the difference between two prices is 29, now this makes more sense. Okay, so this is standard deviation is difference in rupees. Variance, difference in unit square. Okay, so you also have a formula STDEV dot sample. So if it should give you the same number. Okay, same number. Or you can use the square root of variance. That will also give you the same answer. Okay, so that's the difference between variance and standard deviation. Now you have already done this chapter on distribution, isn't it? You know what a distribution is. Now, when I have a normal distribution, or let's say I have a standard normal distribution. There are two kinds of distribution in normal. One is normal. The other is standard normal. What is the difference between these two? If I plot the graph for normal and standard normal, the graph looks identical. It will be something like this. Okay, left side of the graph and right side of the graph are same. That is why it is called as a normal distribution. But what is the difference between normal and standard normal?
In standard normal distribution, standard deviation.
Who's saying?
In standard normal, standard deviation is 1.
Very good. So in a standard normal distribution, then what is the mean value? Good. The mean is 0. So this value is 0. And the standard deviation is 1. So this is -1. And this is 1. -2, -3, +1, +2, +3, etc. This is standard normal distribution. When do you get a standard normal distribution?
Normalizing the values.
After normalizing. Okay, so which method do you use generally for normalization? Z-score. Okay, you convert the data into a Z-score, which is x minus mu upon sigma. We'll do that in hypothesis testing. Okay, what is normalization? So standard normal chart is when the mean is 0, standard deviation is 1, whereas a normal distribution can have any mean and any standard deviation. Okay, so where if it is 5, if the mean is 500, So 495, 490, 505, 510. Okay, that's how the spread is. Clear? For a skewed distribution, standard deviation does not make any sense. Okay. Any questions online? Is this clear to all? So when we are studying the distribution to find out whether it is normal or not, what is the objective of this study? Why should we study the distribution and check for normal?
Because hypothesis testing is mainly based on normal distribution.
Okay, that is one. Anything else? Anything else? See, generally, whenever you want some good results, we want to cover all aspects of the data. Okay, what happens in skewness? Does it cover all data? What happens in the left skew? The majority data lies on one side. What happens in a right skew? Majority data lies on the right side. Okay, so it does not cover the full spectrum. Okay, whereas normal distribution covers the entire range of values. Okay, so you get a good result if your data is distributed that way. Otherwise, you end up with something called bias. Okay, your analysis is based on the distribution left or right. So you are biased towards that part. Okay, that is the reason. And another reason is when you're doing machine learning, the assumption of, there are a couple of assumptions. The first assumption is there are no outliers in your data. The second assumption is your data is normally distributed. Okay, so we have to go with that assumption that it is normal, and then you have to try to convert it into a normal distribution if it is not normal. Okay, so that is the reason why we are so focused on converting everything into normal, whereas 90%, 95% of the time, real life data is never normally distributed. Okay, you will always have skews. Okay, so that is about variance and standard deviation and distribution. What is the next one? The next one is measure of association. What is the meaning of the term association? Correlation. Okay. So it is when I'm doing analysis for two variables, bivariate analysis. I want to compare A and B. Okay. Are they related to each other? Yes or no? So there can be three types of relation when I'm doing bivariate analysis. What are they? So I'm comparing, let's say, effort versus, forget effort. Petrol versus distance. Okay, so I'm filling 10 liters of petrol. So how much distance can I go? Okay, so what kind of a relation exists between these two variables? Positive relation. Okay, so what are the other types of relation that I can have? Negative correlation and zero. Okay, it is zero correlation. So let's say that you got 95% in your last semester, last exam, all the subjects. Does it mean that next exam also you will get the same? No. Okay, so the number of hours that you study, does it translate to high marks? Does the price of pizza depend on the price of petrol? So these are negative, these are zero correlation. Okay. Now there are two measures which determines relation between two variables. One is called covariance and the other is correlation. So there is covariance, C-O-V, and then the small letter R, which is correlation. What is the difference between these two? This chapter, you must have done this. Covariance, correlation. So covariance is the relation between A and B or between two features that tells what is the direction of the relation, whether it is positive or negative. That's all. Okay. Whereas correlation, it gives you not just the direction, but also gives the strength. Okay. Now, petrol is directly related with distance. But how much, what is the strength of this relation? I know it is positive, but how positive? Does it have a 95% strength or 10% strength? Both are positive numbers. Okay, so how positive is that? That is determined by R or the correlation. So if you look at correlation, the correlation ranges from -1 to +1. Whereas covariance does not have any range. Okay, it only has a number that gives you positive or negative. Clear? So let's do a couple of examples, small examples. Now let's say that house price and versus area of a room. Okay, what is the relation between house price and area? So I'm just going to put some random numbers: 700, 660, 674, 552, 820, 845, 730, 900, 1010, 475. Okay. So 700, let's put 56 lakhs. 674 is 50. 52 is 45. 820, let's put 70 lakhs. 845, 72, 730, 50, 900, let's put. Okay, so I'm going to find out what is the relation between area and the house price. So I can do covariance and correlation. So for covariance, I have two formulas. One is for population, one is for sample. So this is a sample. So I'll use COVAR covariance.S. So this will take two parameters. What is my first data? What is my second data? My first data set is area. So I'll select the area first. And my second parameter is the house price. So I'll select this. So this gives you some number. Now, what does this number indicate? positive. Okay, it is 3413. Now from this number, can you tell whether the relation between area and house price is very high, high, or just positive? Can you interpret based on this number? Is it very high? Is it high? Or is this just positive?
Just for
On what, what basis are you saying just positive?
because
Sorry, it is okay. Very high, high, high. Okay, just positive, high. So why is it high? On what parameter are you saying? On what basis?
as the area increases, the price also increases.
That is the positive side of it. Okay, there is a positive relation. But from this number, can you say it is a high correlation or there is a high positive relation between these?
No.
Okay, now to conclude whether it is very high, high, or just, you need some reference point, isn't it? So if I compare 3413 with 3412, then you can say it is just. If I compare 3413 with 1, then it is very high. Okay, so covariance does not have a range. That's why I said in the sometime back, the definition of covariance is it only indicates the direction, but does not show strength. Okay, if you want to find out what is the strength of these two, you need to find the correlation between these two, where the range is from -1, which is highly negative, to 0, which is no relation, to +1, which is very highly positively correlated. So let's find out what is the strength of this. So we have a function called correl, which is correlation. So it takes the same parameters, the first column, which is area, comma, the second column or the second array, which is the house price. Now tell whether the correlation is high, very high, or just positive.
Very, very.
It is very high because it is 0.98, which is very near to 1. Okay, so this is how you find out what is the correlation between two features. So we can try it out with other parameters like where one is increasing, other is decreasing. Number of people working on the project versus the time taken to complete the project. Okay, more people, less time, less people, more time. So you have a negative correlation. Okay, so we can try that out. So let's just try one exercise and see the covariance and correlation values. So you can have number of people working on a project versus time. So more people, less time, less people, more time. You should get negative. So it depends on what kind of values have you put. But you should see a negative number. Okay. And the third kind of relation is zero correlation. Okay. So where there is no relation between the two features, X and Y. So again, what is the use of doing this analysis? You said you have already done linear and logistic regression, so you should be able to answer this.
To find which variables have more impact on the dependent variables.
Okay, that is one.
To eliminate the non-dependent variables and to make it more simple.
Correct. So once again, it goes back to the assumptions of the data. What is the assumption with respect to the data that we have in machine learning? Number one, data is normally distributed, what we discussed some time back. No outliers, we discussed that. The third assumption is there is no multicollinearity. Okay, so multicollinearity means my data, that is my column, should not have any correlation with other columns, whether it is positive or negative. So if a correlation exists between two features, it means that my data has multicollinearity. I should get rid of any one or do something so that this relation does not exist. Okay, so to do that check, we plot the features, the correlation matrix, and find out how many features exist that have these kind of positive or negative correlation. Clear? So if there is no correlation, let's say X and Y, the correlation value is 0.03. So what does this mean? Let us say that I have two features, weight versus price. Okay, and the correlation of these two, I'm getting a value of 0.0315. So what interpretation can I draw from this?
Very weak correlation.
Very weak correlation, correct. Okay, or you can say zero correlation because this is very near to zero. So what does that mean?
These two are independent.
Excellent. They are independent features. Okay, so this is what we want in my data. The features should be independent of each other without any relation. And if I have independent features, that is why in the data we call them as independent features and dependent feature. Okay, why is it called independent? They are not linked to each other. Okay, they should have a relation with Y, but not X and X. Okay, that is why they are independent features. So this shows independence. Clear? Huh.
So like we have the for correlation, we have the range -1 to 1, right? If it is -1, then it is highly negative, and if it is 1, it is highly positive.
Correct.
0 is the neutral one.
Correct.
So when it comes between 0 or 1 or 0 -1, can we say that 0.5 or -0.5 is a neutral for both for that value?
That is a general assumption that you can make.
We can
0.5 because that's the center value. Okay. Now there can be cases where in some domains 0.7 is okay. Okay, you can still take it as independent features, but 0.75 or 0.8 is considered to be correlated. There are domains where 0.2 is also highly correlated. So it is very domain specific. How do you want to treat these values?
So that set will be getting as a reference point, right? From somewhere.
That is dependent on the client, the domain, the project we are working on. So we cannot generalize that every data 0.5 should be the benchmark. That is wrong. For high-end engineering data, 0.2 could be very highly correlated. Laser technology, robotics, even 0.2 is highly correlated. Whereas other areas, 0.56 is okay. No, okay, take it. For example, marketing, surveys and all. You can take that as an accepted feature. So these are specific to domains. Same applies for the negative number also. Okay, any questions? Then we have the last measure of association, which is called COV, coefficient of variation. Coefficient of variation is defined as sigma upon mu. Okay, so this shows how much is the variation I have in my data set. So this is also known as relative standard deviation. Relative standard deviation is also known as coefficient of variation or COV, which is defined as sigma upon mu. So given a data set, you have to determine which data set is going to be better for your analysis. One which has a lot of variation or one which has less variation. So which is more preferred? The one which has less variation is preferred. So how do you find that out? A very quick way is find the mean, find the standard deviation, do the difference, do the division. So whichever has a smaller number, okay, take that. Okay. You want one small exercise on this? You can just try this out. So there are two stock prices. So stock 1 and stock 2. The mean of the first stock is given and the standard deviation of the second stock is given. This is 135. This is 87.5. The standard deviation of this is 1.5. And the standard deviation of this is now the question is, given this information, which stock would you prefer to buy? Or which stock is more risky? Okay, so do the calculation and find out. Use the coefficient of variation and see what are the values. This is actually not 1.5, it is 15.3. Sorry. One is, there's a lot of variation actually.
So for this coefficient of variation, we can directly say, like from the standard deviation, that the data is already too much. The data has too much variation.
But the mean is different, isn't it?
Why do we need mean for it?
For what?
For this calculation? Because solely from the standard deviation, we can say that the data has the variation.
See, standard deviation formula also requires the mean value, isn't it? It is from the mean.
Yes.
So only by the standard deviation we cannot make out. So that is the reason why it takes both these parameters, mu and standard deviation. That's why it is relative. Did you do rank correlation in your class by any chance? Rank, R-A-N-K, rank. Okay, we'll leave that. Online, any questions from anyone? Yogini, Mrinal, Chintamani, Ankita.
No, sir.
Okay. So that completes the descriptive statistics. Next, we go to what is inferential statistics. What is the definition? Inferential statistics is?
From the sample, we draw inferences for the population.
Correct. So from the sample, we analyze and tell how my population will look like. Okay. So in this, we have two main measures. What are they? Estimation and hypothesis testing. So estimation is a kind of guessing that what is the likelihood of this? What is the value? Okay. So what are the two values that I can guess based on the data given? One is the average value, which is the mean, and the other is the standard deviation. Okay. Generally, it is the mean value that we guess. Okay. Now, suppose I say in my next batch, there will be 20 students. Okay, based on this batch, the previous batch, I'm taking an average and saying next batch I'll have 20 students. So is this a good estimate? Is this a good estimate or a proper estimate? It is good. What if 20 don't turn up? Then bad estimate. So I need some way in which I can say that my next batch will have n number of students. So point estimation is not a very good way of determining that number. Okay. So this 20 is called as point estimation. What are the two types of estimation? Point estimate and range estimate. Now I make a similar interpretation based on my previous n number of batches. The number of students in my next batch is going to be somewhere between 15 to 20. Now, which is a better estimate? The range estimate. So here I'm taking care of something called errors. Okay, errors means not mistakes. Okay, when I say 20 people, errors mean some people can join where the number may be greater than 20. Some people may opt out for whatever reason. So the number will be less than that. Okay, so this is called errors. So how do you take care of errors? So in statistics, we have a term called standard error. So we have to take care of, implement this error. And based on this error, we are going to calculate what is my range, which is the minimum number to maximum number. Okay. Can you just wait for 2 minutes? I'll try to get that pen. I have to write.
As compared to the
It was a fine day. So what we need have a coefficient of coefficient of variance.
So we have something called standard error that takes care of the mistakes that happen when you are doing the sampling or the calculations. Now the standard error formula is standard error equals is given as sigma by square root of 1. Okay, this is called standard error. Now in the distribution, I told you that in the normal distribution, this is the value of mean. Okay. Now if I take this as 1, okay, this is called one standard distribution. Okay, now what is the meaning of one standard distribution? It means that approximately 68% of my data lies in this range. Okay, that is the meaning of one standard distribution or one SD. When I take -2, sorry, this means that this area is 68. This area is approximately 95%. And when I have 3 distributions, this is -3 plus 3. This is approximately 98 to 99%. Okay, so we generally call this as 1 SD, 2 SD, and 3 SD. Okay. So now, when we want to calculate our range estimate, so there are 2 factors that we consider. First is what is the mean value, and the second one is how many standard deviations are we going to take. Okay, so we generally refer to that as a value K. So this is known as number of standard deviation. Okay, are we taking 1 standard deviation? Then I get a range. If I take 2 standard deviation, I get a bigger range. If I take 3 standard deviations, I get a much bigger range. Okay, so the formula for range is given as, so range estimate is given as mu, that is the mean, plus minus the value of k. K is 1, 2, or 3 multiplied by standard error. Clear? So this is the relation between standard error and estimate. That is range estimate. Okay, we'll just do one small exercise so that you understand this concept. So I'm just going to create one data set. So this is number of box per packet. Let me see if I have the data here. So 109, 97, 104, 110, 110, 102, 112, 111, 98, 06, 184, 109, 03, 110, 95, 106. Okay. So I have a big packet. Let's say I'm packing some gifts for Diwali, and I'm packing some gifts in a box. I mean, in a packet, some small boxes. Let's say it is chocolates. Now, how many boxes are there in each packet? Is it necessary that every packet should have the same number of boxes? There can be errors. Okay, errors means when you are putting something into that packet, the boxes can fall down, or there can be human errors, whatever it is. So every box need not have the same number. So if someone asks me what is the average number of boxes I have in each packet, okay, so how do you determine that? I can either do point estimate or I can do range estimate. Point estimate will give me one number where I can say number of boxes are so much. But if I have to give a more precise information, I will use number of boxes can vary between this and that. Okay, so let's do this exercise. So let's do point estimation. Point estimation is also the mean value. Okay, so mean, or we can say point estimate, and then standard deviation, which is also a point estimate. So what is the mean value? It is average of So the average number of boxes I have is 104.15. The standard deviation, I can use the sample. Which is 6.46.
So what is the difference between that standard deviation formula for sample and population?
the difference is in the denominator. For sample, it is n minus 1. For population, it is n. Because we are taking for a population all the values. Okay, so we get a more accurate measure. But when we take a sample, okay, now not all samples will be similar to the population. So if we take the same formula, chances are that the deviation from the population will be high. So we want to close down that deviation. So we take n minus 1. You can try with n minus 2 also, but n minus 1 has been statistically proven to be very close to the population mean, population standard deviation. If you look at the formula, it is x minus mu whole square divided by n for population and n minus 1 for samples. Okay, now first let us calculate the standard error. So standard error, what is the formula? What is the sample size? Let's write that also. So n is the sample size. So this is going to be count of (20). So there are 20 samples. Okay. So standard error formula equals standard deviation divided by square root of n. Okay, so square root of so standard error is 1.446. Clear? So now we can calculate what is our range estimate. So I can have 3 values, the value of k, which is 1, 2, and 3. That is 1 standard deviation, 2 standard deviation, and 3 standard deviation. So the formula is minimum value and maximum value. So let me write down that formula here so that we can refer to it. So formula is range equals mu plus minus k times SE. Okay. So plus minus means I'll have 2 values. So the minimum is mu minus k times SE and maximum is mu plus k times SE. Okay. So depending on how many standard deviations I want, I will get the ranges. So let's do the first one and you can do the remaining 2. So when the value of k is 1, that means I'm taking 68% of my population of my sample. So the formula for minimum is mu minus. So mu is minus k times. So k value is 1. So k times standard error, which is this. And then the maximum value is mu plus k times standard error. Okay, so now you can say my average number of boxes in the packet lies between 102 to 105. Okay, so for the minimum value, you can take the ceiling value, the floor value, And for the max, you can take the ceiling value depending on how you want to interpret. Okay, so do for K2 and 3 and see how the ranges differ when I take different values for the standard deviation. Standard error formula, no? Standard error formula is sigma upon square root of sigma is standard deviation. So SD. So यहाँ पे standard error is sigma upon n. So 6.64 divided by square root of 20. Online, any questions from anyone?
So this number from minimum to maximum, it will be the ranges.
Yeah, so this is the range. So if okay, let me write the interpretation. So if I take the standard deviation as 1, that is K equals 1. So I can say that the average number of boxes range from 102 to 106. Now I can simply drag and drop this formula. You don't have to write it. The only thing you have to take care is the mean value is constant. The standard error value is constant. So you need to put a dollar sign in the front. Okay. So E1 is the mean value. So if you put the dollar sign, so that will make this value constant. D7 is the value of K. So that has to change. So E4, again, it's a constant value. So now if I drag this formula down, now you can see that when k is 2, the minimum number is 101 and the maximum value is . Now, which is a better way to interpret the range? Because this takes care of the errors also, whereas the point estimate does not take into account the errors.
So for standard error, we can also say like it's a standard deviation of a population.
Standard deviation is?
No, in this case, the standard error can also be called as the standard deviation of population.
Standard deviation of the population.
Because we are using it as standard deviation, because mu plus minus whatever is the number of standard deviation into the standard error. So it is indirectly standard deviation.
No, this is not a deviation. Deviation is from the mean. From mean, left and right.
Yes.
Here we are trying to find out the mean value can range from which number to which number. So here you are actually going from left to right and from here right to left. Okay, what could be the range where the values can fit? Deviation is how much it varies from the mean on both sides. Okay, two different things. Okay, so that finishes the main measures. Central tendency is done, spread is done, association is done, estimation is done. Now we are left with the big chapter, which is hypothesis testing. How much was it covered in your class? Tell me first. Hypothesis testing. What all did you do in hypothesis testing? Because this is a huge chapter.
One day and
1 day and
2 days.
We did 1 day, 2 days.
Chart then.
Peters, when it comes to Peters. When it comes to air test. When it comes science test.
chi-square. People have different ways of saying this. कुछ लोग चीज कर बोलते हैं ठीक है ठीक. We get confused. या कुछ नया बोल रहा हूँ. Okay. Huh? Anything else? ANOVA. Okay.
One day.
Okay, tell me, what is the base of doing these tests? Why? What is hypothesis testing? Why do we need to do this? What are the two measures that are used for doing a hypothesis testing? But before we do all this, on what basis is this hypothesis testing done?
Data set, population samples.
Okay. First thing is you need to understand what is a Z-score, because everything is based on Z-score. Okay. What is a Z-score? What is the range of Z-score? Why Z-score? Only then you can understand how to interpret those numbers. Okay. What is a confidence interval? Nahi kiya? Then what hypothesis testing did you do without understanding confidence interval?
Implementation.
Theoretical, I don't have any knowledge.
How did you find out what is the value of Z given a value of the probability?
We got the formula that is mu minus. Just the formula.
You know how to interpret a result. If I say the T value of a test is 8.321. Okay,
Yeah.
I'm talking of a Z-score test, for example. I'm talking, yeah. Okay, one way. क्या बोल रहा हूँ मैं? One sample. Okay, one sample Z test. The value of the T statistic is 8.321. You know the interpretation of this?
Now we check out for the P value.
I'm talking of T. You can go with P also. इसका P value कितना होगा? Can you guess? I don't want the exact number. Can you guess how much will it be?
It will be far beyond 0.95.
Far beyond 0.95. तो कितना? 0.99?
Near to 1.
It will be the reverse. It will be a very small number.
0.01.
It will be less than 0.05. Okay, for this number, it is going to be probably somewhere around 0.00002. Very small number. Okay, now why is this so small? वो पता है? You have to know this. Otherwise, a lot of interpretation when we do in machine learning based on hypothesis testing, you will know how to interpret. But why is like this? You will not know. So that is why you have to go from Z-score. Okay. Z-score क्या है? Let's start from the basics. I don't mind spending some time, but this is important. What is a Z-score? Online people, please respond.
Z-score is the point is how much standard deviation away from the mean. So if it's if the Z-score is 1.5, then we can say the data point is 1.5 standard deviations away from the mean.
So Z-score is converting your data into a standard normal form. Okay, that is the first thing. When your data set is not normally distributed, you want to convert it into a normal distribution. One way is converting the data into a Z-score. So this converts the data into a standard normal form where the mean is how much? 0 and the sigma is okay. So when you plot this graph, you will have a graph like this. This is the mean, which is 0. And you have 1, 2, and 3. What is the range of Z? It goes from -3 to +3. Okay, so this covers the entire area, which is how much? 100%. Not 100%, 99.999%. It will never be 100. So whenever we are getting the value of the T from the calculations, we have to look at something called as a Z-score chart. Have you seen a Z-score chart? Have you referred to that? You know how to find the values of Z given a p-value or given a p-value.
Rows and columns.
You know how to interpret it? Okay. So we'll do one exercise based on that. Okay. So first thing is convert, understand Z score. What is the range of Z? So given a Z score, what is the p-value? Given a p-value, what is the Z? Okay. So this is the basis for hypothesis. Because when you look at the probability values, so if you look at the Z score, you have the probability values in the center. And on the labels, you have the Z scores. So the probability value determines what is the confidence interval. Okay, 99%, 99.9%, 97.5%, 95%. Okay, so that is the confidence interval. With what confidence are you saying that my assumption is valid? Okay, those are statistical confidence values. Okay. Do you have the chart with you now? Can you open the chart? Now you can just download one form. I mean the chart. So see. So you'll have this chart, something like this. So the data goes from minus 3.4 to plus 3.2. Okay. So I'll give you, let's do one exercise and you will understand how to read this chart. So find the probability that randomly selected weight has a reading of 1.58, let's say, kilograms. Now notice that this is a Z score value, okay, not original value. Now, when you are given these kind of problems, the assumption is given that the mean is 0 and the standard deviation is 1, okay? If this is not given, then I cannot use the table. So how do you find out what is the probability given the value as 1.58? Now, is this a Z score? This is the actual value. Okay. What is given is mu is 0, sigma is 1. Okay. So we have to convert this into a Z score. So what is the formula for Z? X minus mu upon sigma. What is the value of X? 1.58. So 1.58 minus 0 divided by 1, which is 1.58. Okay, now Z score is unitless. So don't put kilograms or grams in Z. It is unitless value. Now find out what is the p value. So now go to the chart. Now the area in the center represents the probabilities. That is, all these are probabilities. The one on the left hand side is the Z score with 1 decimal, and the area, the values on the right represents the Z score with the other decimals. Okay. Now we have to find out 1.58. So let me just zoom this. So Z can have positive number and negative number. So we have to look at the positive number. So where is 1.58? So first look at 1.5. So this is 1.5. This is 1.50, 1.51, 2, 3, 4, 5, 6, 7, 8. So the answer is probability that the weight is 1.58 kilograms. The probability is how much? 0.9429. Clear? Now the reverse. When you are given a probability, how to find the Z score? So this is how much p value. Is this a p value or is this the probability? There's a probability, not p value. Okay, big difference between these two. The probability is
0.9429.
What is the p value?
It is greater than 0.5.
1 minus of this. Okay, it is the area to the right. So p value represents the area, the value which is a rare occurrence. Okay, that is what is the p value. So don't confuse between these two. Okay, good. Now let's do the reverse. Find the Z score that represents the bottom 95% of the data. What is bottom 95%? So start from the diagram. Hypothesis testing always start with the standard normal diagram. So we are looking at 100% as the area, correct? Which is the zero? Left or right?
Left.
Left. So bottom 95 is 0 to 95, correct? Bottom 95. So can we say approximately this area is bottom 95? Maybe we can take this point. Okay, so this point is, this area is bottom 95. So is that the same as top 5? No? Why not? Bottom 95 is the same as top 5. Don't compare the areas. Okay, I'm just saying that if bottom 95 represents this, that is equivalent to the top 5, whatever is remaining, isn't it? Because it is a standard normal form. So what is there here will also be here. Now we have to find out given this area as 95%, what is this point? Okay, earlier we had given a point, what was the area? Now we have given an area, what is the point? So at 95%, what is my Z score? So Z given probability equals 95%. So the first thing that we have to do is convert this into a probability, that is percentage to a number. So how much is 95%? 0.95. And since there is nothing after 95, we'll put 0. So 0.9500. Now what is the Z that represents this area? So go to the chart and now see, do we have an area which is 0.9500? So let's check. What did you say? 1.7. Okay, let's find out. So do we have a 0.95 anywhere? There is 0.9505. So this is the closest. So we want 0.9500. So we have 0.9505. Then we have one number less, which is 0.9495. So 0.9495. So 0.95 lies in between these two. Correct? So what is the Z score now? What is the Z score that corresponds to 9495? 1.6, 0, 1, 2, 3, 4. So this is 1.64. This is 1.65. So what is the average? 1.645. So the Z score for this area is how much? So this value is 1.645. Okay, so this area corresponds to 0.95. And how much is this area to the right? 0.05. Does this number sound familiar? Where did you use this? Whenever we do interpretation, we always refer to 0.05. Now you know where the number comes from. It is the area to the right at confidence interval 95%. Okay, now earlier I asked this question when the t statistic when you calculate is 8.1. What is the approximate p-value? So where is the value 8.1 going to lie? To the right of 1.645. So let's say this is that value. If this is 8.1, what is the p-value? It is going to be this tiny portion to the right, isn't it? And how much is that? It is less than 0.05. So it is significant. We'll come to that part later. Okay, so this p-value is less than . Understood the basic concepts, how to find p-value and z-score. Online, any questions from anyone?
No, sir.
Shall we take a break now? 11 o'clock.
Yes.
So we'll take a break and come back and do some quick introduction to what is hypothesis, what are the steps to do the hypothesis testing, and then a couple of questions, and we'll end today's session here.
So when will we start ML proper?
Next. We were supposed to start last week, but when I was talking to people, a lot of concepts were not clear. So I thought, let me do a quick revision first.
So and then will be from this scratch, right? It will not be a revision like what we are doing.
Have you done any ML? No. So yeah, it will be from the scratch. Take 15 minutes and then. So break time online, we'll meet in 15 minutes. Okay, let's start. Okay, you already have done the hypothesis testing in class, so I won't get into details. What is the why should you do hypothesis testing? Tell me this.
To understand whether our assumptions are correct or not.
Okay, so this is mainly to check whether the assumptions that we have made on a sample, okay, does it tally with the population? Okay, it's all about telling about the population. Okay. Now I have a hypothesis. Now there are two things on which I can make a hypothesis. What are those two things? There are only two things on which you can make a claim or a hypothesis. What are they? Those are the
Accepted.
those are the techniques of
Exception and rejection.
no. You can make a hypothesis on two things. One is on the mean, and the other is on proportion. Isn't it? You can either say that the average weight, average IQ, average mark, average speed is so much. Isn't it? You never do standard deviation or anything else. It's always average. Then what is proportion? You say majority, most of them, isn't it? So these comes under proportion. So when you are when you are making a claim, you can either do it on the mean or you can do it on the proportion. Okay, only these two are done. So when you make this claim, you cover all the possibilities. What are the possibilities that you can have? One is something is equals a number. Something is greater than the number. And the third one is less than the number. So this will cover all the possibilities. Okay. Now we'll come to the next part. What are the steps? Before I do that, confidence interval. What is the default confidence interval? If nothing is given, 95%. So you always do this as 95%. What is the Z score at 95%? Z score. We just calculated it. 1.645. What is the alpha value? 0.05. What is the other name for alpha?
Significance.
Or critical value. Okay, significance value or critical value. Now we'll go to the steps. I don't have space. So hypothesis testing can be done in three ways. One is left tail, then right tail. What is the third one? Two tail. So how do you determine whether my hypothesis is a left tail, right tail, or a two tail? On what factor?
It depends on the alternative hypothesis that we are assuming. So,
Correct. It is based on the alternate hypothesis. Okay. So if that is based on alternate hypothesis, what is a null hypothesis? Why is it based on alternate hypothesis? The choice of tail.
Because null hypothesis is based on just the negation of our argument.
Okay. So when we talk of hypothesis testing, there are two parts to it. What are they? Null hypothesis and alternate hypothesis. How do you determine null hypothesis? Or how do you write null hypothesis? H0. Or you can also write HA. Okay. So generally, people use H0. What is alternate hypothesis? H0, H1. Okay. Or HA, HB. People, they mix up this. Okay. So whatever what you want to use, that is up to you. Now, when I state or when I make a statement, how do you put the statement into the null hypothesis? How do you put the statement into the alternate hypothesis? What are the factors? So first we'll talk of what are the steps in hypothesis testing. So number one is you start with the claim. That is the statement. Number two is the opposite claim. Okay, this is the statement as it is. Okay, so let me write one statement here. The average mileage of a car is 15. Okay, this is a statement. This is not not a null hypothesis or anything, just a statement. So what is my claim here? Average mileage is 50. Okay. So average mileage is 50. What is the opposite claim? Is not 50. So you will simply write here not 50. What is the third step? You form the null hypothesis. So H0. Now what is the null hypothesis in this claim?
average mileage is 50. Average mileage.
So what symbol should I put here? Mu, because this is average. So I'll put mu and alternate is also mu. Okay. Now remember, whatever may be the assumption, the null hypothesis will always contain the equal sign. Okay, that is how you form the null hypothesis. So null hypothesis is basically all the good things. Someone is innocent unless proven guilty. Same concept. Okay, so null hypothesis always equals something. So here what will I write? Equals 50. Now what is the opposite of equals? It is not equals. Okay, so that is step number 4. Alternate hypothesis is not equals 50. Now, step number 5. Now you determine the tail. So tail is based on alternate hypothesis. Now, it is a very simple formula how to determine left, right, or two-tail. Null will always have equals, isn't it? So alternate can have three symbols. Either it can have greater than. So if it is greater than, it is right tail, pointing to the right. It can have left, that is less than, that means it is a left tail, to the left. Or it can have equals. Equals means two tail. So here I have a not equal symbol, so the tail is Does it make any difference if I do a single tail or a two-tail test?
Yeah.
What is that?
The critical value. So if it is two-tailed, then it will divide between the two tails.
Good. Okay, remember this. When you have a two-tail test, alpha gets split into two. So here, what is the alpha value? Given nothing, what is the alpha? 0.05. What is the tail? Two tail. So what is the alpha going to be? It is going to be 0.025. Because it is a two tail, so the alpha will split into two parts. Alpha by 2 here and alpha by 2 here. Okay, if you do not do this, there is a chance that you will get the wrong interpretation. Clear? If it is one tail, then you can take the value as it is. This is only for a two tail. Step number 6, after you determine the tail, then you calculate the t statistic. So t statistic will depend upon whether you are doing one tail, one sample Z, one sample T, two sample Z, two sample T, or ANOVA or chi-square. Okay. So they have different formulas for different tests. So calculate the t statistic. Then step number 7. What is it? Step number 7. Okay, it is either P or P. But we are more interested in the T. Okay. Next is interpretation. Interpret status. So we'll see how the interpretation is going to work. So assume that I'm doing the hypothesis at 95%. So Z is 1.645. And this is 0.95. This is 0.05. Now the area is always to the left. If you look at this diagram and scroll up. Okay, what does it say? Entry for Z and area is to the left of Z. Okay, so that means if Z is this, area will be to the left always. Okay. So I have given this area as 95%. So what is this area called and what is this area to the right called? That determines whether my claim or the hypothesis is, the null hypothesis should be accepted or not accepted. Okay. So this area to the right, this is known as rejection region. And the area to the left is called? No, you cannot accept it because we are correct. It is failed to reject. We can call this as acceptance also, but when we are dealing with samples, we cannot say that we are completely accepting the claim. Okay. So it is failed to reject or FTR. Now we can determine whether my claim has to be accepted or not accepted based on the T statistic. So T statistics is nothing but a Z-score that is getting calculated. Okay. So point number 7, interpret T statistic. Now T statistics can have only two values. It can either be greater than the Z reference, which is, okay, I'll just put here, Z reference is how much? 1.645. Okay, so the T statistics can either be greater than the Z reference or it can be less than the Z reference. Okay, it can never be equal. Now, depending upon the value that you get for the T statistic, your interpretation will vary. Now, let us look at both these cases when it is greater than the Z-score. So let's take one value here. So let's take Z calculated as, let's take 3.779. Okay. So here the Z calculated is, or the T calculated is greater than the Z reference. So that means where will the value of Z calculated lie? Right of the Z, isn't it? So that means here. So if it is lying to the right, it means in which area it is lying? Rejection region. So what will be the interpretation? Reject null hypothesis. Okay, when you are rejecting null hypothesis, it means that this is not valid and this is valid. So in this example, if I'm getting the average mileage is 15, the T statistics is 3.5, I am rejecting the null hypothesis. So that means the average is not 15. It is either less than 15 or it is more than 15, but it is not 15. Clear? Now the next one, if I'm getting a Z-score of, let's say, 1.117. So where will this lie? It will lie here to the left of Z reference. So this will be Z equals 1.117. Which area? Fail to reject. So that means fail to reject null hypothesis. That means I cannot accept the null hypothesis. Okay, completely I cannot accept it. It may be true, may not be true, but unless I test all the values of my population, I cannot say. So here I can say if this happens, fail to reject the null hypothesis. Here you can write except H1. And here I can say inconclusive statement. Inconclusive means we do not have enough evidence to prove our claim. When we reject the null hypothesis, we can say we have enough evidence to prove the claim. Is this clear to everyone? Tail. Step number 5. How to select? Tail is determined by the alternate hypothesis. What is the symbol in the alternate? If it is having a greater than sign, it means right tail. If it is having a left symbol, that is less than sign, it means left tail. If it is having not equal symbol, it means two tail. Now, what is the use of this hypothesis testing with respect to machine learning? ये कहाँ use होगा? Main areas where I can use this concept. Of course, you won't be doing all these things, okay, not in detail, but you should know the interpretation. So where is this used? Number one, it is used in time series. Okay. In time series, you have to determine whether my data, there is a concept called stationarity of data. Okay. So is my data stationary, yes or no? How do you determine? Using a hypothesis testing. Okay. There's a test called Dickey-Fuller test, ADF. Okay. So it uses this. Number two, after I make my forecasting, there is an assumption that says my errors have a normal distribution. The same thing is there in linear regression also, if you recall. So how do you test whether my errors have a normal distribution? Once again, hypothesis testing. Is my data normally distributed, yes or no? Same concept. Okay, hypothesis testing. Okay, so these are some areas where we use this concept, at least the interpretation of the values. Okay, and one more important thing, how do you determine the best features in your data set? Once again, it is done by the hypothesis testing. So when we do the linear regression, I'll explain this, okay, why it is done. Okay, any questions? Online people, any questions?
No.
Okay, so let's so what are the different types of hypothesis testing? Okay, so before that, let me give you one small exercise. Let me see if we have understood the basic concepts. The mean of a liquid can is can the claim and null hypothesis be the same?
Yes.
Okay, so let's find out. So do this exercise. Mean of a liquid can is 30 ml. What is the claim? Mean is 30. Opposite claim? Not 30. Okay, I will put one more, we'll put the tail here. Okay. What is null hypothesis? Mu equals 30. H1 not equals 30. Is the claim and null hypothesis same? Yes. Tail? Okay. Clear? Let's try another one. Most school principals are women. What is the claim? Okay, tell me, is this, what are we talking of here? Proportions. Okay. So now tell me the claim. What is the claim? Most school. Okay. So most school principals are women. Then opposite. Is this most school principals are men or is it not women? Which is right? Not women. Now tell me the null hypothesis. That is the claim. So in H0 and H1, we are replacing the claim with the symbols. So what symbol will you put for null hypothesis and alternate hypothesis? What is the definition of null hypothesis? Always equal sign. Okay. So we will put equal here. Now tell me what will come into the left of equal sign and right of equal sign.
Percentage wise proportion.
So we're talking of percentages, isn't it? Proportions or percentage. So we will put P. Okay, mu is for mean, P is for proportion. So P equals what? How much? P equals Roman. We need a number.
It should be a figure.
What figure will I put here?
95.
Greater than 0.5.
Sorry?
Greater than
Greater
Greater
than
than
hypothesis is equals. Why
So
90?
any number greater than
P equal to
0 point? Why 0.05? What is the meaning of most? Most means? So in terms of figure, what is most?
More than
Greater than
more than 50?
0.5, correct?
Greater than 0.
Now tell me what number will I put here?
0.5.
0.5. Now what is the alternate hypothesis?
Less than. It should be less than.
Equal to 0.9.
Greater than, less than, equals to, not equals to.
Less than.
What is most?
more than
So where are you accounting for this? So what is P? Sorry, what is alternate hypothesis? P greater than
0.
right?
Why? Because claim is most school principal are. So the alternate should be most is greater than 50%.
No, that is the claim. Okay, don't go by the claim. Claim we have already taken care. But what is the null and alternate hypothesis? That will determine whether my claim is right or wrong. Isn't it? So mathematically, how do you write this? Null hypothesis is always equals. Okay, it can either be equal or less than equal because most is greater than. So what is remaining? Less than or equals to. So if I put less than equal to it at 0, so what is remaining is my claim, right? So that is what I have written here. But since equal to is only applicable for null hypothesis, so I'll remove less than. So now my claim is 50%, alternate, null hypothesis is 50%, alternate hypothesis greater than 50%. Now, is my claim same as my null hypothesis?
No.
So that means claims need not always be the same as null hypothesis. Okay, claims can also be the alternate hypothesis. What tail is this?
Right.
So if you look at the symbol here, it is greater than. Clear? So let's write down the list of formulas. So we have 4 types, 1 sample, so this is t-test and z-test. Then we have 2 sample, t-test and z-test. Then we have n sample. This is ANOVA. And chi-square. Now the first 5 tests that we have here, can you tell me what is the name of this? There's a special name that we give for these tests only. These are known as parametric tests. Chi-square is called as non-parametric test. Was this covered? Parametric versus non-parametric? No? Don't worry about remembering the formulas and all that. It's very difficult to remember. Anyway, it is not required. Okay. But for calculation purpose, it's good to know how these values are done, calculated. So for the first one, which is 1 sample, first we'll see how to find out the mean and then the proportion. So for the mean, the formula is x bar minus mu divided by sigma upon square root of n. So x bar is the mean value of the sample, mu is the mean of the population, sigma, standard deviation, n is the sample size. And for proportion, the formula is Z equals. You can either call it Z or you can call this as T statistic. So both are same. We generally call this as Z calculated. And then we have the Z reference. So Z calculated is this for mean. And for proportion, it is P hat minus P divided by square root of P into Q divided by square root of Q. So P hat is the sample proportion. P is the value that you get from the null hypothesis. Q is 1 minus P and N is the sample size. Okay, so I'll just solve a few questions. So a sample of 706 companies found that 61% of chief executives were men. So which formula will you use in this case? Proportion formula. Okay. You want to try this first? So follow the same steps, step 1, step 2, at least for the first 1 or 2 questions. Then you can directly use
So can you please switch it back to the formula?
Yes. Done.
0.2.
Hmm?
0.02.
0.0. What is this? The t statistic. So the z calculated, you are getting 0.021. नहीं कम तो नहीं आना चाहिए इतना. So we can start with the claim. Most are male. Then opposite claim is most CEO are not male. Then the null hypothesis. What should we put in null hypothesis? P equals 0.5. Isn't it? What is P hat? That is 0.61. That is the sample proportion. I guess so. When I got such a small number, लगा कुछ तो mistake हुआ है. Okay, what is H1? What is P hat? What is Q? 0.5. 1 minus 0.5, 0.5. And what is N? 0.06. Okay. So first write all the values, then it is easy for you to interpret. What is alpha? 0.05. What is the tail? Right tail. Okay. What is the Z reference? Z reference is 1.645. Okay. Now we have to find what is the P statistic. So the formula is given here at the right. P hat minus P. So P hat is 0.61 minus P is 0.5 divided by square root of 0.5 multiplied by 0.5 divided by square root of 706. Okay, so now find out what is this value. So 0.61 minus 0.5. This is 0.11 divided by 0.5 into 0.5 square root is 0.5. So this is 0.5 divided by square root of 706. So around how much? 26.57. So this is 0.11 divided by, so 0.5 divided by 26.57. So do this calculation and tell what is the number.
0.11.
How much?
6.11.
6.11. Is this number right? 6.11?
8.8.
8.85. How come you're getting different numbers? 6.11. So two people have got 6.1. Let me also try. So 0.11 divided by
5.8.
5.8. Okay. 5.84. 5.845. 5.845. So this is 5.845. Just check, must be some minor mistake somewhere. Now tell me the interpretation. You have calculated the t statistic. You have got one number. Now, what is the interpretation of this number? So, reject the null hypothesis. Okay. Now, what is the null hypothesis? So, we are rejecting this null hypothesis, correct? That means we are accepting the alternate hypothesis. So, that means this is valid. So, what is the meaning of this? If we are accepting the alternate hypothesis, we are saying that the claim is true. Since T statistic is greater than the Z reference, we are going to reject the null hypothesis. That is, we are accepting the alternate hypothesis, and that is most CEOs are men. So we can also write this as there is sufficient evidence to support the claim that most CEOs are men. Clear? Online people, any questions? Did you get this number 5.845?
Yes, sir.
Done? Okay, we'll just do one more and one for the mean. Which one? The Yes.
one sample.
Why is it called a Z-test? And why is it not called as a T-test?
Number of samples.
The table would be a
Number of sample graders.
Correct. The number of sample is greater than 30. Okay, that is the difference between Z and T. Okay, if you are referring to a T table, T-test, you have to refer to a different table, by the way. Okay, it's not the same. T ka alag hai. Z has a different one. ANOVA has a different table. And chi-square has a different table.
Greater than or equal to or greater than?
Which one?
Number of samples should be greater than or equal to or just greater than? Okay.
Greater than or equal to
Greater than or equal to. Then you have to consider
Z.
Okay.
Z or Z. Z is the American way of saying. We call Z. Most of them don't understand Z. Wahan pe they call Z. So given a sample mean of 83. Iska just understand this question properly. Okay. Given a sample mean of 83. Sample standard deviation of 12.5. The sample size of 22. Is the hypothesis that the value of the population mean is 70 means to the alternative that it is 70. So which formula will you use for this? The mean formula.
X bar minus mu divided by sigma minus sigma divided by under root of n.
Yes, I'll just put it here. Now here you have to remember one thing. The formula here is X bar minus mu upon sigma by square root of n. Okay. Now do we have sigma here?
yes.
No.
Standard deviation is there, but for what?
Sample.
Sample. Sigma is for population. So we have to replace sigma with S. Okay. Formula will be the same. But when you read it, it is going to be sample standard deviation. Okay. That's the only difference. In this question, do we have a claim?
Yes.
Yes.
Yes. Population is
More than
more than that.
Is that a claim? Question follow क्या है? Test the hypothesis. So there is no claim here. So you directly start with HCs. That's why I said read this question. There is no claim in this.
We need to use your redistribution, right? We can use redistribution. Since sample size is very.
Do the regular one first and then use the redistribution. Yeah, it will be the T table.
Yeah.
Because sample size is less than 30. Do you want to do the other examples, two sample, ANOVA, and I-square? Or shall we next week directly start ML? How confident are you in?
We can do one thing, sir. We can take those examples as a homework. If we find it out,
Like homework is fine, but you because we had some issues understanding. A lot of them have understanding why are we doing this. Formula is fine. O minus E by E square will get some number, but why are we doing that? That is where most of you are having issues, and this is what we are going to use in the analysis also. If I say okay for feature selection, use I-square. For logistic regression, I-square is good. Then you should not blame. Right? How I-square is used in logistic. Okay. So if you are comfortable, then fine. We can do it as a homework and review some questions. Or we can do what I can maybe on a Saturday, instead of spending 4 hours, just touch upon the basic concepts of what is ANOVA. Why are we doing ANOVA? Then I'll give you one question, you can solve it at home. Solving part is easy. Why is ANOVA? How is ANOVA related in linear regression? Because both are identical. If you look at the concept of ANOVA. So it is used as a feature selection tool, where the independent variable is something and dependent variable is something. So that when you have this combination, you use ANOVA. When you have dependent variable and independent variable, both are categorical, then you use chi-square. Okay, so that is the concept. I'll just touch upon these basic concepts. I'll give you some questions, you can maybe solve it, and then start. And it's already two second week now. Okay, done. Yeah, what is the number? 4.87. 4.87. P statistic equals 4.87. What is the reference?
critical value.
This is T statistic. What is the Z reference or the T reference?
2.08.
Hmm?
2.08.
2.08. Where do you get this number? T table. So what is the interpretation of this? Clear? So we can say that the mean is greater than 70. All done? Online? Have you all finished? Okay, we have around 10 minutes. Let me try to understand what you know in ANOVA and chi-square. What have you understood? I saw some examples you have solved. What is the full form of ANOVA? Analysis of variance. So now tell me, what is the use of ANOVA? Find the difference of what?
Means.
The means. And what are you trying to prove by using the ANOVA?
If the difference between the means of two groups is statistically significant. If the two groups are different or not.
It is if the means of two or more groups. Okay, it is not two. Two is two sample. Okay, this is we are talking of n sample. If the means of two or more, three or more groups are having the same mean or different mean. That is the use of ANOVA. Just to a simple example. If I am considering 10 countries, and I want to find out over the last 50 years, what is the GDP of the country, the average GDP. Okay, are they similar or are they dissimilar? Okay, so if I have to find out the average GDP of these 10 countries over the last 50 years. So I'll have mu1 equals mu2 equals mu10. This is my null hypothesis. Okay, means are same. What is the alternate hypothesis? Any one pair is not equal. Okay, it is not everything. If any one pair, the means are not same. So it can either be mu1 is not equals mu2. There can be two countries which have the same mean, isn't it? For example, if you take Russia, if you take the European nations, small countries can have similar means. Okay, so I'm finding out whether two countries are significantly different or statistically different in terms of their averages. So if I'm able to get that, so that is the reason why we write mu1 not equals mu2. Mu2 can be equals to mu3. So as a mathematical thing, we write mu1 not equals to mu3 not equals mu2. Okay, so this is the GDP. Sorry, this is the null and alternate. So what does this give? It gives something called as a F ratio. This is also known as F score. Okay, so it gives a ratio between among variance and around variance, between groups versus within a group. Okay, so this ratio is known as ANOVA. Now, in terms of its significance or its relation in ML, so we have a feature, we have a Y variable. Okay, now where is this used in ML as a feature selection tool? Now, what is X here and what is Y here? In this example, can you tell me, can you guess what is X and what is Y? What is the feature? What is the value that we are going to predict? Correct. Country will be the feature and Y will be the Now, if I have to generalize this, I can say that to use ANOVA, my feature has to be categorical, right? And my Y variable has to be only if I have this combination, I can use ANOVA. If both are numbers, then I can use correlation. Okay, when my feature is a category, Y is a number, then ANOVA. Now, in terms of its interpretation, again, for doing an ANOVA, you need an ANOVA table. Okay, so that's a different table. So if it is significant, so how do we do the feature selection? We'll do this, we'll discuss this when we do the linear regression. Don't want to stuff too many things. So this is ANOVA. So the F score, if you look at the formula, it is around variance upon among variance. So let's not do that. You know the hands-on how to do it? Have you solved it? Okay. So I'll just give you one. Let me see if I have. Okay. Okay, try to solve this. You can do it at home. We should not wonder what to do with this. That's why I wrote ANOVA. Okay, so now you have 4 categories and each category has values. So you want to find out whether the means of these are similar or at least one pair is not same.
So we can do it in Python or we have to do.
As long as you know how to interpret it, doesn't make any difference. Okay, so that is ANOVA, and we'll quickly cover chi-square and then we'll stop. What is chi-square used for? What is chi-square first? This is the symbol for chi-square. Chi.
Matches the population.
I'm surprised how only the formulas were used to solve a problem. That is the easy part. And why did you not ask that? Give a background of what is chi-square, where is it used? You should have asked this question. Okay, no issues. See, chi-square is used to, what is the full name of chi-square? Is it only chi-square? It is called chi-square test for independence. Okay, this is the full name, chi-square test for independence. So what are we testing here? So let me give you a small example so you can correlate. Now I have a feature and I have a y variable. The y variable is whether an employee is likely to resign or not. Okay, so this is a case of attrition. Okay. So attrition, if I say yes, it means employee has resigned. No, employee is still with the company. So what kind of a feature is this? Categorical data. Okay. Now, what are the factors that affect attrition? There can be one or more. There can be a mixture of numeric and factors. Correct? So let us leave aside the numeric part. What are the factors or what are the categorical data that can affect attrition? Okay. Gender. Can the gender affect attrition? Okay, I do not know. Okay, I'm just writing this here. Educational qualification, does this affect attrition?
Yes.
Could be. Okay, unless we prove it with the data. Okay, then let's take one more. Let's take city.
Might be affected.
Sorry?
Might be affected.
Might be. Huh? So I'm just writing it. Now, what are these columns? Categorical?
Yes.
So chi-square is used to test whether categorical and categorical have a relation or not. Whether gender affects attrition, yes or no. Whether educational affects attrition, yes or no. Whether the city that you are staying affects attrition, yes or no. Okay, So if it affects, it means that gender and categorical have a relation. If it doesn't affect, it means that they are independent. So that is the name given here, test for independence. Whether gender and category, gender and attrition, are they dependent or independent? So the null hypothesis is they are dependent. Alternate hypothesis, they are independent. Okay. So H0, the variables are H1, variables are and you use the chi-square table to determine what is the T statistic, and then the usual result, the interpretation will be the same. So here you have to take care of two things. One is what is the observed value? What is the expected value? Do you know the calculations for expected? So how do you find the expected value? You have to find the row total, and then you have to find the column total. And then you have to find the group total. Okay, so row total, and then column totals, and then you have the sum total. Okay. Let me see if I have a question based on this. Okay, so that's all we have for today. So try to solve this and see if you're able to interpret the results. Okay, if you have any questions, we'll discuss this on Saturday. And we will start with linear regression. So online people, any questions, any doubts from anyone?
No, sir.
Okay.
So how much time will it take to complete LL part?
So what all do you have? Linear regression, logistic regression, then decision tree, polynomial. You have that? Achha. I think they have introduced this new polynomial. Polynomial regression. Can you forward me the syllabus? I think it has been changed. Earlier it was not there, polynomial. So thank you all online. See you next week.